Thank you all for coming. This is the Startup Grind Kitchener-Waterloo. A little reason why we're doing Startup Grind. First of all, it seems to be, we're going to hold them to this, or at least check it out, one of the largest startup networks in the world. They say 100 cities, 300 chapters. I've looked into it. There's a lot of active events going on. And what we're hoping to do, and what we're going to explore with everyone we can after every event, is who out of those 100 cities, 300 other chapters can we connect you with, and can we connect these companies here out into the rest of the world. So we're hoping to make Kitchener-Waterloo and Startup Grind a very, very top of funnel for the ecosystem here and make all kinds of connections all over the world. That's the short version. The event today is Dr. Brandon DeHart, and we're going to be talking about problem havers, people here on stage, in your case sitting on that chair, talking to us about the challenges they're seeing in the industry right now so that founders in the room can try to think about how they would figure out how to solve these problems and bring those products to market. The hardest thing we keep hearing is, as a founder, as a startup company, whenever I'm trying to get to market, how do I get FaceTime with my actual customer to really validate and probably invalidate all of my assumptions? Get to the right solution as fast as possible. So if we can help you move the needle in a material way so that in the next 3, 6, or 12 months, you actually solve a problem that matters and there's a connection made and ideally, a business milestone achieved, that's what we want to hear about. Those are the milestones we want to track, and that's what we want to show from the mountaintops. So let's get into it. Dr. DeHart, welcome. Thank you for coming.
Thanks for having me.
All right. Real quick, we're going to go through a bit of an origin story. What brings you, the manager of RoboHub, maybe you tell us a little about RoboHub and how you got there.
Okay. So RoboHub really started as a shared research space at the University of Waterloo. Half dozen professors, a couple of departments, really kind of a general space to pull robots together, work across multiple disciplines, fields, verticals, whatever it might be. Very quickly after they kind of got their funding, they hired me on to be effectively lab manager, lab tech, buy robots, take care of robots, take care of space, etc. I put my PhD to part-time and started doing that full-time basically right away. And very quickly, actually, RoboHub, as I think Global Mail called it a terrarium for robots. It's like a big glass space in the middle of a big atrium full of a bunch of robots doing things, so it kind of fits. We started getting asked to do all kinds of stuff. So K-12 outreach, undergrad courses, grad courses, professional development, partnerships and collaborations and all kinds of different things. So at this point, we're we are the home of basically all things robotics on campus. So the support side, infrastructure, companies, startups, education, outreach, kind of all the things. We're kind of that single point of contact. And ramping up staff to support all of those things in better ways. But and my kind of how I got into that, I did mechatronics undergrad at Waterloo.
Yeah.
I was in the second class with all the folks who started, ClearPath and AvidBots in the next year, and BufferBox and 2G and a bunch of those ones. And then did my master's in kind of architecture, interactive installations, things like that. Worked for them for a bit, and then came back because I missed teaching to do my PhD, because you have to have a PhD to teach engineering in Canada. Always been a terrible academic, so didn't really publish much, didn't chase grants, don't want to publish much and chase grants. So I kind of created this position a little bit because the folks who got the funding were like my academic supervisor, 2 profs I'd taught for, one that I'd worked for in undergrad, et cetera. And they were like, Brandon should do this job, right? Brandon, yeah? Yeah. Okay. So, and then we kind of made it what it is.
Yeah, and the RoboHub lets you do a lot of teaching.
It lets me teach,
facilitating,
but also nicely, it lets me teach only if and when I want to.
Right.
Because it's not like you are required to teach X courses a year or anything like that. My main thing is RoboHub partnerships, robots, et cetera, and then I can teach, I can do research, I can do the pieces that are the fun bits.
So, the partners, though, there is a business model to RoboHub, I understand.
Yes. Yeah. So during COVID, we put together like a full sustainability plan so we could be effectively self-funded.
Okay. Yeah.
Because we very much started with like federal money and provincial money on the research side, and then we had some, the Advanced Manufacturing Consortium was also putting in some funds for us to kind of support SMEs in southwestern Ontario. And then, we've got a partnership program, so companies, startups, not-for-profits, multinationals, et cetera, can kind of come in and get access to facilities, robot lending library, expertise, software repos,
Right.
consultation, whatever the different pieces are.
Yeah. So that's the context that we're going to end up talking
Yes.
about today. Before we doing that, though, back to the teaching. I know there's a way you open your classes.
Yes.
There's a question there, and
Yep.
this is to the audience. We figured we'd do a little question to the audience, but let's do that real quick.
Okay. So generally, I mean, when I start most of my classes, the very first thing I do is just ask them all, what is a robot? Can you define it in 10 words or less? And then pick apart whatever definitions I hear or give counterexamples until like somebody has decided that a dishwasher is a robot and another person has decided that a Roomba is not a robot, and they kind of break it down. But since we're kind of in this kind of robots and physical AI and which one is inside what bubble and whatever, I kind of have a little bit of a different question for all of you, which is, what's the difference between physical AI, embodied AI, embedded AI, and edge AI? Because all of those terms have been used for various things, and all of them have been in robots or not.
Do
have been
you all of you
used
know
or
what they
not.
all mean? Do you have like clear definitions for each 4 of those categories?
Did that just sound like me saying the same thing 4 times, pretty much? Embodied has limbs, okay. Okay. Okay, so if it's on hardware inside something, then it's embedded, okay. Edge is like, yeah, there is a computer and the AI is on that computer instead of on a server, okay. Are we dropping here? So the thing that's most amusing to me.
Let me just jump in here because
Okay, yeah, go
until
for it. You got folks at the door too.
oh, good.
Go for it.
Yeah. Until we had our little warm up for this a week ago,
Yep.
I had never really heard the term physical AI. And what
Yep.
you're telling me was this is Jensen,
It's Jensen, yeah.
and this is like early 2025.
Yeah, pretty much. It was the Jensen talk when they decided that robots were part of AI, and NVIDIA decided robots were part of AI. And the label they gave to that was physical AI. And now that's the one that all the politicians and the software folks and the investors and everybody is like, oh, physical AI, that's robots, right? And that's edge, and it's all the things. So it's the like common bucket term that has only existed for like a year and a half-ish.
And it's not a technical term. It's
Not at all.
Yeah.
No.
Not like the other 3, maybe.
No, and
Right.
so the interesting piece is the other 3 have all been used across academia, across products, across like all kinds of different things over the years. And all of them can be physical AI, they can be a robot or part of a robot, they can be all the things, but they're all weird overlapping Venn diagrams of different things. So part
then
of the challenge is like, what are we talking about?
Yeah, exactly. So
Yeah.
all clear now, right? Exactly.
Totally makes sense
This mic?
now?
Yeah. I'm going to adjust the volume real quick. And while I'm doing that, so your partners come in, they bring you a problem, you're in some sort of commercialization, facilitation workshop, and they're talking physical AI, and they're talking embedded, and they're talking embodied, or are they, this is all news to them, or what? Like walk us through like that product roadmap, that process from day one, they send you the email to you've got something prototype you're working on.
So a lot of the time, what ends up happening, so we do kind of 2 main streams, I would say, on the partnership side. There's kind of the the community piece, the events, career fairs and symposia and all of those different things, where it's mainly about getting people in a room, right? Bringing in students, government, not-for-profits, companies, startups, researchers, everybody, putting them in the same room to talk about the problems. Because most of the time they have the same problems, or one has a solution to the other one's problems, but they don't talk the same language. They have jargon, they have whatever, so having those things actually work together is a lot of translation work that we do. And then the other thread is, people coming in with a problem where they're trying to solve the problem, but they don't know how to find the solution. And actually, I was having this chat with Nikhil earlier of like, I want to solve this thing, I don't know where to find it, I don't know who's doing it, I don't know what language they're using or what words they're using to describe the thing that solves my problem. How do I figure out how to get there, right? And most of the time, what ends up happening is companies are coming to us or partners are coming to us, either one, and they have a problem, and we end up being able to say, because we do a lot of work on the kind of the integration side and software and kind of human-robot interaction and interfacing and all those lovely things, that like this partner sells 90% of that, and this one sells another 5%, and the piece that's left is an open question in research, so we'll help you research what the solution is. Or we can find someone in the space that's built something open source, whatever it might be.
And is that like the same playbook you run every time?
No.
It's
so.
But there must be like they walk in and you go like, okay, you fit in one of these 3 or 4 categories.
Yeah, it's kind of like the funnel of funnels.
Right.
Piece, right? Of like, oh, you're doing a product, it's going to be an internal versus you're selling it versus a startup coming in to say, hey, I want to do this thing. And sometimes we have to disabuse them of like, oh, well, these people sell exactly what you're trying to make, or all of these people would benefit from what you're trying to make. Or, I had a conversation earlier today of like someone who wants to become a startup partner in order to incorporate robots into a project. And the robot they were describing is actually the robot that a different partner sells. And they didn't actually want to build a robot, they just wanted to incorporate robots. So it's like, why don't you guys play together?
You should talk together,
and then we're good, So there's a fair amount of that, particularly at the startup side.
So we talked about corporate, but at the same time, I think it's not just corporate, right? There's municipal, there's government, it's across the board, right?
Yeah.
Are you seeing, the reason for this conversation is, what are the challenges you're seeing? Do you want to bucket them corporate, municipal? Is it different? Is it all the same?
No.
Is it different today than it was a year ago? Is there a progress you see?
The labels are different because Jensen has introduced physical AI, but other than that, really no. It's mostly folks want to they want to move stuff or people around.
They want to move stuff or people around.
And or people,
generally. People, okay.
Or they want to add some kind of automation or tooling or process or whatever it is to help their employees or their customers or their patients or their citizens or whatever it is. And usually that takes the frame of, I want something to save them time, I want something to save them, make them safer, reduce back strain, take them out of a environment that is full of melting rubber or fumes or whatever it is. It's usually a thing where it's like, I want to save the people from having to do the thing, or I want to move people and or stuff to or from somewhere. Right.
So sounds to me these are problems that have existed for like thousands of years. These are
forever problems.
Human civilization problems. What's happening today? Like, why RoboHub? I'm trying to put you on the spot here. Why RoboHub? How is it that you're solving things a little bit that's different enough, that matters enough, people are coming at you, and they're saying this is working super well because we didn't see this. This was a gap we couldn't cross. We couldn't, you know what I mean? I'm trying to, because I actually don't understand necessarily how I can understand automating a warehouse. I can understand environments where putting a human is going to be challenging necessarily, underwater, in space, heat, cold, all that kind of good stuff.
So those are
those seem like the obvious
extreme environments,
ones, right?
I would say, right? So like you're going non-oxygenated, you're going heavy cold, heavy warm, you're going poison, you're going radiation, all of those things, right?
Yep.
The general playbook in robotics for a long time now, probably 15 years, when it comes to mobile, when it comes to anything like that, is the dull, dirty, dangerous piece of like, is there something dull, dirty, or dangerous?
Dull, dirty, or dangerous.
Probably a robot should do that because you're not taking advantage of the creativity and the problem solving and all the things that we're so good at, right?
Got it.
And generally I end up leaning on Moravec's paradox. Moravec is like a very poorly known Canadian who basically the only thing people know about him is this paradox. But effectively he said like things that are really, really hard for people to do are easy for computers and robots, and things that are really easy for computers and robots to do are hard for people to do.
Yeah.
So if you have processes that you've had to do a whole bunch of work to make it work for a human, probably you should put a robot there. And if it's taking a ton of work for you to automate or get a whatever, you should just make it easier for the human to do the job. And lots of what we end up doing is in that space, where it's like a human-centric task. It's teleop. It's moving a person away from a particular piece of a problem. It's getting them to be able to move a thing, touch a thing, augment their strength, augment their dexterity, whatever it might be, but not removing them from the process.
So human stays in the process.
Right? For the most part, the human's in the process, or the human's working next to them, right? It's human-robot teaming, it's things like that, right?
Thank you for bringing that up, because I know you're involved quite heavily in ethical AI and ethical robotics and how to get them working together side by side, humans and robotics working side by side in a safe manner. Yeah. Is that something your companies, your partner companies are coming to you with these challenges?
Some of them are coming to us with those. Some of them are groups, so like the Open RoboEthics initiative that one of our research members actually started when she was doing her PhD out in UBC, or things like the RoboEthics competition that we've been running for a number of years now. Things where it's like, assume the robot does its job.
Assume the robot does its job.
Let's actually figure out the moral, ethical, social, psychological, et cetera, impacts, legal impacts, regulation, all of these things that we actually need to solve and figure out before someone will insure this, or before a school will take it, or a hospital, or an airport, or whatever, these things.
Well, it seems like those are the checkpoints along the way of getting an actual scalable business model around this device.
Yes. Yeah.
Because
as soon as you want scale, you need regulation has to play nice, which means you have standards, which means you have laws, which means you have insurance. Yeah. All of those things. That's why, like, for example, even in industry and warehouses and like places that have been doing robotics for 50, 60, 70 years, depending on where you're at, the only robots that have actually had certification and standards and regulation and all those things are either robots that are bolted to the ground or bolted to a table, whatever, or wheeled systems that can't tip over.
Okay.
Whether there's an arm on it or not, or two arm, whatever it is, cannot tip over. Yeah. If it can tip over, if it's on legs, if it's interacting with people, any of those things, there's no rules. So basically they are treated as like random custom machinery or an RC car. Like basically you have consumer protection and that's it. So there's no industrial protection, there's no insurance, there's none of that because there's no rules yet. And we're helping build those right now. We're working on standards, we're building a lot of those things. But like, robot on the sidewalk is only governed right now by a municipality's rules. Right. Or one in a hospital is only governed by the same rules as the bedpan. It's just an object that is in that space. There are no actual...
Do you see those standardizing in the near future?
Yes. I mean, we're already working on, public area mobile robots for things like delivery in hospitals and things. We're working on the balancing piece on an ISO side. There's some UL ones that are working on it.
Right. So the example
there's
was...
There's lots of pieces that are going to that, right?
I remember you telling me the example as a robot walking down the street, delivering a package, what happens if the power goes out? Yeah. Does that robot fall over?
If it falls over...
And that thing's 300 pounds, it's carrying a 200-pound package, and there's kids nearby.
Yeah. If it hits a kid, it hits your car, it breaks the window in your store, it breaks whatever the package is it's delivering. Yeah. Nobody's insuring that right now because the robot can't be insured. Right. So all of the industrial applications, the pilots, the whatever, especially when you come to something like humanoids, they're all pilots because they have to be because there's no rules yet. Yeah. Right? And like the only place that you can properly deploy things like that right now is someone like Hyundai who bought Boston Dynamics. Mm-hmm. So they can deploy Boston Dynamics humanoids into their lines because there's no other company they have to worry about. Right. They're just basically putting their own systems into their other systems.
Yeah, they're self-insuring.
So,
that makes a lot of sense.
Yeah.
I want to talk about a success story, but I want to hear from the room, are there any specific industries in the room being represented right now? Ag tech, warehousing, drones, logistics,
mobility, health. care, assistive,
Healthcare, yeah.
healthcare.
Healthcare's in the room, well represented. Yeah.
Okay.
Healthcare. So I've worked with many interventional radiologists. I've been in the inside of angio suites and operating theaters.
Yep.
A lot of handheld stuff because every situation's different.
Yep.
And everybody I've talked to has talked about, we're going to do this telerobotics, we're going to do telemedicine.
Yep.
And it has I've never, I mean, you see the pilots, you hear the success stories, but it's not, I can't.
It's pilots, yeah.
Yeah, it's pilots. I'm not in rural Quebec getting a heart valve replaced today by someone in Norway, right? So, healthcare.
So there's kind of three pieces to that challenge. One of them, particularly for the telerobotics or mobile anything up north, battlefield, pick your place where like you don't want doctor next to patient, or caregiver next to patient, or whatever it might be. Connectivity is huge.
Yeah.
You have to have most of the robots we have. Probably 2/3 of the challenges we end up having is not the mechatronic systems. It's not motors, it's not sensors. Like those things are relatively robust. It's connectivity, both internal network, external network, connectivity, getting information on and off of the system, like all of those things. Mm-hmm. So we're working with a bunch of telecoms, we're working with a bunch of folks in that space looking at how do you compress, how do you send it, what kind of latency is necessary, all those things, right? And particularly things that are not data types that have been sent before. So we are very, very familiar and good at, especially here in town, sending data, sending text, sending videos, sending pictures, right? Every one of us has a device that's doing that every single day. How do you send a texture?
Yeah.
Or a force, or the shape of an object, whatever, right? Those things are not well standardized. There aren't formats that play nice with that. There's not lots of compression and encryption, and because there's a whole other cybersecurity privacy piece that's also attached to that. So there's that piece, but then also we get into, on the health side, there's all kinds of rules in terms of if something's going to touch a patient versus be in an operating room versus be inside someone in a surgery versus whatever. So there's a lot of aspects there that, again, it's the regulation and everything that slows things down. But a big part of it there as well is you need to, if you're going to use it as a tool, A, it has to be reliable. B, it has to have a guy down the road who can fix it. And C, the person who's using it has to know how to use it as well as they know how to use the piece, the handheld, whatever that's at the end of the arm.
Yeah,
right?
yeah. And that last part, the conversations I'm having are, how soon, how quickly, is it even feasible to be pushing that logic to the edge so that there is some sort of embedded AI in the device, and the surgeon who's in Norway is guiding but not executing every step.
Yeah. Well, and it ends up being a similar conversation to what we've been having in education for a while now, where you're moving from the the sage on the stage, all the information's coming from me, I'm doing this, whatever, to that the guide on the side where you're
classroom.
Here, this is how you do the thing. Let's do it together. Let's work on the thing. You do the application, you do the whatever, right? It's a similar kind of process where it's and I think that one of the major challenges, especially with something like surgeons and surgery and a lot of those things, pilots, same idea, whatever, is but it's me and I'm responsible and I am taking the ownership and it is on my whatever that this is going to happen. So if I tell it to do a thing and it doesn't do precisely what I make it want it to do.
Who owns the liability?
Whereas it comes back to insurance and liability and regulation, all those things again, right? Particularly on the health side.
Yeah.
But in our experience, most of the time that's not what people are coming in looking for, right? They'll go to a Da Vinci, they'll go to a whoever if they want a robot that's going to cut inside someone.
Right.
Our significant strength, and one of the things that I think is going to be the major growth space when it comes to across health, manufacturing, municipality, take your pick of a vertical, it's the two pieces that I talked about at the top of the core things that we continue doing and are regularly doing on a regular basis, which is making things move around, the mobility piece, things, stuff, people, whatever, and that human-robot interaction, interface, whatever it is. Whether there's a person on the other end of that robot, whether it's a tablet on wheels that's rolling up and you're having a conversation, or you're physically operating it, whatever it might be. It's the piece where we can magnify and augment the people, right? So like if you have a person using a tool and they're wrecking their arm, is there an exoskeleton that can help their arm so they can continue doing the thing they love doing? Or if they hate their job and want to do something else, then the arm becomes a robot arm, and someone who maybe can't work there because of who knows what can now do that job, or whatever it might be, right? There's an accessibility piece, there's like a training piece, there's a connectivity piece, and they all kind of fold together into this like, how do you help the people, right? How do you do robots for people?
Yeah.
And then also how do you move the stuff around to enable
Said
people,
robot. Yeah.
right? So
You said augment and magnify.
yeah, augment, magnify, scale,
Yeah.
right?
Yeah, the
Which is
human,
all it
yeah.
is. Like
Yeah.
you want to do construction, you want to magnify up and bigger. You want to do surgery, you want like 10 centimeters of movement to be, 10 microns of movement inside the person.
Yeah.
Right? You want to go both directions.
Yeah.
More dexterity, more strength, whatever the thing is you're trying to augment. Right?
Let that 85-year-old expert surgeon do microsurgery, even though there's tremors now.
Exactly.
And he wouldn't be able to do that otherwise. But now he can facilitate the process.
And the nice thing too is that all of those things are not single verticals,
Right.
which is lovely for startups. P.S. If you're not stuck in one vertical, that's awesome. Right? If you're moving stuff around, or you're helping someone communicate with someone remotely, or you're helping someone do something remotely, or whatever, those apply across dozens of verticals, right? So even with like tremors, for example, right? You do something that can cancel tremors in an intelligent way and understands how that person is trying to move, and they can then train
Got
it
it.
to them,
Yeah.
whether that's a personalized physical AI thing, whatever edge embedded embodied thing. That technology can also then apply to the person with Parkinson's feeding themselves,
Right.
and also apply to someone who has a rehabilitation process where they currently have tremors because of something temporary, and they're trying to train themselves so it counters that, but less and less and less every week
Yeah.
or every whatever, right?
That's
There's
interesting.
a rehab piece, there's a healing piece, there's a job piece, there's a personal piece. Yeah.
So when you work with your partner companies, municipalities included, hospitals, they're coming to you with a vertical typically. How quickly are you able to help them say, hey, this one problem is actually a horizontal slice across multiple verticals here? Is that a conversation that happens pretty naturally?
It generally happens fairly naturally, but mainly because of the weird way that RoboHub grew up, I guess.
Okay. Say more.
Because we started very much as 6 profs across multiple disciplines, across multiple departments, et cetera, doing very different things. It was like a humanoid person, 15 years ago, 12 years ago, and a swarming drones person, and a magnetic levitation person, and a
Cool.
human-robot interaction, whatever. And it was like, we're all going to do our own things, and then we'll try to figure out how to make them work together. So from day one, basically, my role has been where are the connections and who is playing in these connections, and then I continue to learn and grow and build a team that is planted in this kind of interdisciplinary space, not just within engineering or within STEM or whatever, but across. We've got members economics and film and biokinematics and law and like all over the place, right? So a lot of it has become that kind of what is the interface to the robot, but like not as a physical interface or in addition to the physical interface, it's also the social, environmental, chemical, sustainability lens, health lens, all the other pieces, right?
And it sounds like maybe you didn't plan it this way, but as people come in,
it's like self-fulfilling.
Yeah,
too,
it's self-fulfilling,
yeah.
and you can see the patterns replicate. This we could replicate in these 3 or 4 because they've got the same problem.
Well, so the interesting piece, especially sitting at the intersection of government, not-for-profit, academia, industry, education, we're seeing, with thousands of co-ops going out and coming back every year, we're seeing like, oh, there's the new thing over here, and the new thing in here, and the new thing in here, and they all want to come work for RoboHub. And as they're solving problems for us, they're like, oh, I heard you talking about the thing. You can do this other thing from, insert discipline here.
This sounds like an incredible part of the program. The value.
It's helpful.
And yeah, okay.
It helps.
This is, the cross network
Well, and even if we say horizontals across academia and the verticals in industry, we have horizontals where like a prof or a whole lab or multiple labs are focused on like, how do robots physically hand things to people? Like a whole lab, that's all they do.
Yeah,
or like, here's a whole lab just doing...
Sounds simple, right?
Whatever, right?
Yeah.
But like digging in deep, looking at hesitation, looking at intent, looking at all these different things, and then you say like, oh, well, if you're doing that, and these guys are doing this, and these guys are doing this, put those together, and you have a system that vertically can go do whatever in health or industry or whatever the thing is, right? So,
sounds like you're growing.
Yes.
And I hear there's an event coming up in the fall.
There is an event, so there's a few. So, Autonomous Life Conference is coming up in August.
Autonomous Life, okay.
Canadian Robotics Council Symposium is September 21st. ROSCON Global is in Canada this year. That's going to be like 3 days of thousands of robotics folks in Toronto. And then that Friday, we're probably going to run a demos and exhibitions day. And then we're actually going to run our next symposium the week of Canadian Thanksgiving. So October 12th, I think it is, that week.
And did you get your venue for that one yet?
I don't have a venue yet because we grew out of our venue. So I think I'm going to have to do multi-day, or I'm going to need to do something. I don't know.
I'm
trying to figure out that because, we hit 300 people, and I was like, I have to literally cut off registration because I'm violating fire code by like 10 people in my room. So But,
so there you go, October, Thanksgiving week.
That week, yeah.
Somewhere in town here. So. Yeah. Good. Anything else? We can throw it up to the room, but unless there's something else on your mind.
Happy to answer questions, talk about RoboHub, talk about robots.
Questions in the room, we'll open it up. We're not going to be able to hear you on the mics, so we'll repeat the question, but we might even not be able to hear you anyway because of like the kitchen and the party going on over there.
Because of our lovely venue.
It's awesome. I love the dynamic like ambient sound in here.
Yeah.
Maybe I didn't hear it right, but are AMRs certified?
So AMRs are...
The question?
Are AMRs certified was the question. AMRs being autonomous mobile robots, which are differentiated in industry from AGVs, autonomous guided vehicles. Basically, guided vehicles are going to have tape on the ground, whatever. They're going to follow that thing. AMRs are more like what our folks in town, Auto Motors, which I guess is part of Rockwell now, do. And basically, they can drive around without the tape and without the guidance. They're kind of navigating and things. They are certed because they can't tip over. Because as long as you follow their spec, they cannot have enough of a high enough center of gravity, and they actually measure how much weight they're carrying before they take a corner and things. So they, based on their safety spec and based on following whatever the rules and the guidance of whatever in their data sheets are, cannot tip over. So they're good to go. The challenge is when you have someone who is doing a narrow-based system that is quite tall, or with an elevator. Forklifts sometimes are at risk in that space, depending on if they've been designed properly or not. But forklifts have their own lovely challenges. But things like people that are trying to deploy even like a wheeled humanoid. So you've got wheels on the bottom, an elevator, upper body, arms, head, whatever. If you're going to have it pick something up in its arms, and you're not actually paying attention to how much it weighs or whatever, and that thing can tip over, literally the second it can tip over in your risk evaluation, it has now become a random custom piece of hardware that no certifier or insurer is going to touch. Yeah, which is painful. But you could put an arm on an AMR, and as long as that arm is still working within the specs of the base and not heavy enough to tip it over, Nikhil is nodding because he's very happy about that because he works in arms on AMRs. Then you're fine. That's also, you can cert it and you can do ISOs and you can do all the fun things. But yeah, that's literally the extent of what is defined in, which one is it? There's like the 15.6 or whatever, whichever one it is, I always forget. But the one that's like, these are robots, but those are the only ones they actually say exist. Yeah.
Question now. Where did you draw the line of genuinely deployable manipulation?
Where would I draw the line of genuinely deployable manipulation?
Being the hardest class of passive
So in terms of...
Could you repeat that last part for...
Sorry. So in terms of kind of because manipulability is kind of the hardest part, well, not that specific word, but like manipulation and dexterity in particular is kind of the hardest part. Which ones are deployable? Are you wondering specifically like scalable or can be deployed as a pilot and eventually become scalable? Okay. So scalable, so particularly manipulation, and we've heard it in the space, we've heard kind of dexterity or the hands or whatever is kind of that last piece that needs to get solved. I think they're just blaming the hand because they can't get regulation to catch up, but that aside, really the extent of manipulation that you can get at now is on the order of a system with, I would say, 10 to 15 total degrees of freedom. So if you have, let's say, an AMR on the base, you've got 3 there, you've got maybe a 6 or 7 degree of freedom arm, probably you're looking at a 5 to 7 degree of freedom hand. It's not going to be these like 24 DOF every single way the human hand moves, whatever ones. Because they're just not reliable enough. Even the very impressive, what was it, Neo 1X video that came out a few days ago. Even in that video, you could see the seams splitting and you could see pieces coming apart because it was just doing demo motions. That's not in a factory. That's not with sharp surfaces. That's not grease and grime and all the things, right? It's already coming apart just from moving quickly, right? So you're going to be in that space. Something like the hands that Mercy Robotics down in Cambridge makes, where it's like a 5 or 6 degree of freedom. It can operate like a drill, right? It has a separate trigger finger. The thumb can move around, whatever. That's kind of the limit of usable end effectors, I would say, right now. In terms of the limits, though, as long as you can pick it up with, a 3-4 degree of freedom hand, so whether it's multi-finger, whether it's air, whether it's vacuum, whether it's positive grasp, whether, whatever it might be, the main challenge still is coming down to the vision piece. Because if you've got things in fixtures, you don't need vision. And if you have a fixture, you can put another fixture on to grab anything, right? You can make the complicated fixture so that a simple robot can grab it, whatever, right? It comes down to things like bin picking, random bin picking, unwrapping things, rewrapping things, anything that hasn't been automated to date in a space like automotive, where they're working on like saving 5 cents on a vehicle is actually worth doing sometimes, right? If they haven't chased it there, generally it's because the problem is more expensive to solve than the people that are currently solving it. And we're getting closer to that piece of like, oh, people don't want to do this part, right? Those dull, dirty, dangerous pieces. Especially when and we've been in half a dozen factories in the last few months, where it's like, oh, my people have to lift really heavy objects. They have to hang something for powder coating. They have to be in a bunny suit inside a paint booth to catch, the little nooks and crannies that the automated painter can't fit, all of those kinds of things, right? It's always, we want to figure out how to automate or solve or robotify this thing because the person is at risk or wrecking their back or, nobody wants to do this job. Like we have 2 guys right now, but nobody wants to do this from now on. Those things, some of those are scalable places to deploy because you can put AMR with an arm with maybe like a 3 or 4 finger hand on it these days. Anything beyond that, you're in that same pilot space. So, sorry? Fastening is an interesting one because if you design a jig properly, then you can do a lot of fastening. But again, you get into the challenge that we were talking about earlier of like, and most of the, I'll call it humanoid slop right now on the internet is like, it's choreographed. It's playing back a motion, but it has no idea about forces. It has no idea about interaction. It has no idea about, how slippery the ground is, whatever. It's literally just playing back some motion that it has seen with no concept of what it's actually doing in the world, right? As soon as you fold in force, so you can do like a reliable peg and hole task, you need that piece and you need the precision and dexterity to align something like a screw in the right axis. Once you have those things, and those are even challenging for us, right? Like we adjust based on what we're feeling, right? You throw your keys on the table, you don't pick them up by very carefully finding the thing, you slap your hand on the table and drag until you feel keys and then close. That's all force, right? You can close your eyes and do the same thing, which means there's no vision attached to that, right? Basically, everything right now is based on vision or based on the model, which is like, sure, you can have forces and things, but you're not measuring them. It's the force piece, it's the touch, it's the texture, it's all of those things that's kind of the barrier we're at right now. That's going to open up a ton of stuff. And we have force torque sensors in all the joints for, I was going to say cobots, but we're not allowed to say that now, for robotic arms designed for collaborative applications, because they changed the standard. You're not allowed to say the robot is collaborative anymore. But they've got joints that have force and torque and all those things. But even still, they're not sensing at this level, right? So like the difference between this and this is different here, but not here. Which means that you have to put all of that intelligence as to those two things being different into the controller right now, because the hand doesn't have the ability to sense any of that yet. At an industrial level, at like a one-off build a humanoid for your investor level, absolutely. You can do touch sensors that are super fine, everything. But like have it survive water and the world and grease and getting poked with a box knife, there's just not there.
I saw another hand up. Did that get you where you needed? Yeah? Super. Thank you.
If we stick with the healthcare today, where do you see, if you look at time horizon, say 3 years, which could be a definable time horizon for this scenario, what is the most likely application that a robot can solve in a healthcare space? Not only with capacity of how technology is today, this versus this, but also commercially.
So the question is, in kind of a 3-year timeline, what is the most likely success story we're going to see or hear? I'm going to paraphrase a little bit. In kind of healthcare space based on deployability and certification and all those fun things. And cash, yes. And commercially.
Yeah.
That someone can
will
make
pay
money
for.
at.
Yeah.
Yeah. I was actually having a conversation about this very thing yesterday in our what does RoboHub 2.0 or RoboHub at the national level or whatever look like conversation. Really what it's coming down to is a race between surgical and I'm going to say assistive, but not in the way that healthcare usually thinks about assistive. So assisting the nurses, the staff, the logistics folks, the shipping people, it's all the ancillary things that enable the medicine to happen, let's say. So if we were going to give it a clean label, I would say it's going to be a robot that's there for the people, not for the medicine, if that makes sense. So it's not going to be a surgical robot. It's not going to be cutting someone open. It's not going to be in there. It's going to be like one that is handling moving dirty linens and scrubs and pillows and whatever around under the hospital or in a secondary elevator or something like that. It's going to be ones that are in a long-term care facility, let's say, that are enabling someone there to have a conversation with their kid, their nephew, their spouse, their whoever, outside of visiting hours or whatever it might be, in a way that feels natural, right? So it's giving that, maybe it has an arm, maybe it's going to play chess with you, maybe, whatever that thing is, it's going to be the enabling the human connection piece. Again, it's for people, not for the medicine. There's arguments about that is also helpful on the medicine side, but medicine, capital M, of knives and drugs and things, not lowercase m of people need to do stuff with people to be better. That's really where it's going to be, right? It's going to be in that space. So it's healthcare, yes, but it's going to be helping with mental load, physical load on nurses that are overworked and understaffed. Again, it's the moving stuff around. It's the people.
I'm going to take Cam's question and say, in the next 3 years, where do you think, if you had to pick one, what do you see moving forward quickly?
Oh, again, it's going to be, and the nice thing is that they can take this on themselves because they have the capacity in terms of risk. It's going to be long-term care facilities and aging in place. And it's going to be systems that can help both the carers and the carees live better lives in those spaces. Because that's the piece, you don't need force, you don't need a lot of those things, and a lot of the algorithms and solutions and everything that we've done with AMRs and done with ARMs and done with all these things can then do that job, right? They can drive around without running into people, they can
Right.
carry objects, you can give it a thing, it'll take it somewhere for, carry your groceries for, whatever. Those things are here.
So,
Yeah.
I mean, it sounds like if I was to look 10 years, I could say each year we're going to scale linearly on, in relation to the number of degrees of freedom and sensors that we can actually process both.
And transmit is the other thing.
And transmit, but there's the mechanical, and there's a network layer, there's the engineering layer, but there's also the social, the dynamic, the insurance, all that stuff.
Yes.
As we can put all those building blocks in place,
Yeah.
that will basically paint your roadmap.
It takes, and it takes a while. And I think, one of the critical pieces that you just hit on is when you have a system that's going to be deployed, you have to care about the people aspect, the logistics and legal and compliance, all the things. But there's also, and one of the things that we work on a lot at Waterloo actually is the trust and acceptance piece, right? Of like, does the person actually want to use it? Do they care? Do they think that it is a good thing for them, for their work, for their environment, their home, their whatever?
Do I want this thing, or do I want to kick it down the stairs?
Right?
Right.
Because if you don't have buy-in from carer and caree, it's going to become just like the robot at Eastside Mario's in here in town, or it's going to become like half the research robots that people invest all the money into and one student uses it, and then it sits in the corner gathering dust.
Right.
Because it is too specific, or it is not useful enough, or it's too slow, or whatever the thing is, whether it's UI, it's interface, it's trust, it's whatever. If people don't want to use it and they would rather do whatever the task is that it's built for, they just won't use it. It will just sit there gathering dust.
Anyone else? Please. Did you catch that?
So how much simulation do we do, and when is the simulation to reality? And what are the obstacles in that space? Yeah, definitely. Yeah, so sim to real is an entire field of research in kind of robotics and automation and social robotics and all of those various things. Much harder to do on the social side because simulating people is like the goal of the AGI folks, so that's a whole other can of worms that I'm not going to jump into. But for the most part, simulation is the core piece where you're doing, if you do have some kind of AI piece, it's where training happens, or the initial training at least. It's where you test control algorithms. It's where you test the fundamental physics pieces. Because the core physics we can simulate, the things that are challenging and even still challenging are things like touch, friction, stepping, soft interaction, stuff like that, where generally you need to do some kind of hardware in the loop of like, everything is simulated, but then the robot pokes a chunk of skin or a cadaver or whatever so that it has a better sense of how that thing might actually work, right? So there's a lot of software, there's a lot of simulation. For the most part, on the research end, the students, the researchers, et cetera, they're going to simulate things, then they're going to bring it in with some components in reality to make sure that the hard parts, whatever it is, whether it's a sensor, whether it's whatever it is, makes sense, and then they'll go to full systems. And we support primarily the full sim and the simulation, and then we help them to build whatever that kind of in progress piece is. On the industry side, in general, my strong recommendation is to build on things that have already been verified in simulation so that you can go to the hardware piece. Because if you are caught up in the simulation side, there's 1,000 different things that you can solve in simulation space that will have no bearing whatsoever in reality. And academics will happily chase every single one of those and fix it and solve it and build the new software and build the new library and do the whatever. But in the real world, for the most part, a lot of those little trails, that long tail, are going to be washed away entirely by friction or whatever that you didn't model in the simulation and you then have to spend the time on. So a lot of the time it's about finding a hardware piece, right? Buy an NVIDIA Thor and buy an arm from someone who has building ARM for 20 years and buy, or actuators if you're gonna make your own arm, whatever. You wanna make sure that the pieces that you don't have to start from scratch on, you benefit from the lengthy history, whether it's algorithm, whether it's motor, whether it's full arm, it's wheeled base, it's whatever it is, because robotics inherently is a interdisciplinary integrational field, and if you want to do everything from scratch, then you'll be 90 years old before your robot does anything. You have to lean on and live on and build on software, hardware, sensors, actuators, materials, whatever, that have already come out and been tested and proven. So for the most part, my strong recommendation, if you're not doing a PhD, chasing research funding, whatever, simulation is great for something like a digital twin, where you're actually doing verification or things like that. But solving problems in simulation is an academic endeavor.
So you are saying go to the real world as fast as possible.
As fast as possible, yeah.
Okay.
Like
Is that what you're
literally, I
saying?
recommend people do cardboard prototyping before simulation 90% of the time.
Really?
Yeah. Yeah.
Figure out the problems you actually need to solve and then go simulate solutions.
Because half of the things you're going to end up
Right.
solving in sim or in your AI training data set or whatever aren't real. And you won't see half of the problems you've learned into in the real world until you're in the real world.
Yeah, but I can see an argument both ways. Until you have an actual 80% hardware prototype anyway, you could simulate your initial prototype in, to get you an idea of what you want to
and
build.
build a Frankenstein
There
like
you
Miguel
go.
did.
Comes.
Right? Because that's one of the big things. With research members, with partners, with whatever, they come in, they're like, hey, I want to build one of these. Like, cool. What is the piece you actually want to build right now? Because if it's the software, here's a mobile base, and we'll bolt a robot arm
Right.
to it, and we'll put a camera on it. Okay, now you have a Frankenstein hardware of the thing that looks like what you're wanting to do. Solve your software. That's the piece you actually care about. That's the piece you want to do, right? Because one of the things that we started with, and I think this is one of the reasons that we've been so successful, is when we first started, and still across most of robotics research, if you come in as, let's say, a master's student, and you come up to your prof and you're like, oh, hey, I want to do a problem in this space, for the most part, you're going to then spend a term finding a robot that's going to fit and do the job that you want if your prof doesn't have one, and then another term working with them to try to find funding to buy it, and then another term figuring out how to use it, and then another term building all of the baseline software so it can move around and things. And now you're one term away from having to submit your thesis, and you haven't actually done the thing that you showed up to do in the first place. You're like 4 or 5 terms in, and now you can start working on planning or grasping or whatever it is, right? Whereas because we have expertise, we have staff, we have technicians, we have physical robots, we have simulations, we have Docker containers where you don't have to build up an entire software library and install everything, whatever, we can get researchers. I've had undergrads get started on what 5 years ago would have been PhD level research in like a month, because all of the other foundational stuff is there, and they can just work on and focus on the thing they care about.
Right.
And then basically that's the model that we have now brought to the partners.
The robot, right. So you can stand up their stack really, really quickly.
Right?
Yeah.
Yeah.
Super. Please, Maddie.
So an easy question for Maddie.
Can you repeat it?
So I'm going to paraphrase and let me know if I have it. So in the current geopolitical landscape, and with the acceleration of all of the lovely fun things of, buy Canada, building Canada, where are we at, where are we going? Where are the strengths that we have, and where are the boundaries in terms of kind of this family of technology? Is that? Okay, so where are we doing well, and where do we have work to do relative to the barriers that are in this space, definitely. Okay. So some of the places we're doing very well are in things like, thank you, things like collaboration across a ridiculously large geographic space, both within country and externally. There are huge numbers of Canadian innovators, companies, programs, hardware, et cetera, that are being sold in and used in every theater in the world. I saw a post the other day from like random American university and another one from a European one and whatever, and I looked at the actual robots they were using, and it was like, oh, that's an arm made in Montreal, and a mobile base that's made here in Kitchener, and a hand that's made, whatever, right? So we are already on the stage when it comes to hardware, and when it comes to even on things like I don't know how many of you know this, but Connect Tech in Guelph is the first company that NVIDIA asked to make Jetsons, which are the thing that run most of the compute and hardware across robotics and edge AI and all of those things. And they've been doing that. They were literally NVIDIA's like first hardware partner, where they were like, please make things, because they do hardened embedded computers and whatever. So they've been doing that there for, I think I was at their 40th celebration when they transitioned, new CEO, et cetera thing. But like we have had that strength in this area for a very, very long time, across compute, across manufacturing, across integration, communications, telecom, like all of these different things. But for a very long time, we have been, as a nation, the folks that sell components and sell systems to other people to use and apply. And often, although it's getting less now, we were the ones selling stuff in, and they would put it together and then sell it back for twice as much, because they did the integration, or they did, whatever. So we have a significantly higher number, especially in the last, I'd say 2.5 years, of folks doing that integration software, build it together, put it together, and some of that also like pull in pieces from elsewhere, build it into an integrated system, and then sell that out. More and more companies are doing that here. Partially because of the political landscape, partially because of rules around buying and the tariffs with the states, and cybersecurity and privacy issues with some of the other countries. There's lots of different things that are affecting that, but we're doing a surprisingly good job, especially given our track record of not wanting to do this for a very long time, of becoming that integrator of pieces. And because most of those pieces that folks were using were coming from Canada in a lot of times, a lot of cases, that has then accelerated as well. Because then some of the things that they're making are built, designed, assembled in Canada from parts made in Canada, which is a whole thing, and most places can't do that, right? They don't have the natural resources, they don't have the space, they don't have the people, whatever it might be. So we're hitting above our weight class, let's say, for a lot of those. One of the things that we still haven't really figured out, and they're trying, is how to fund and support the innovation side. Because, for example, robotics still is not a category or a checkbox or an item or a whatever in any of the budgeting things, in like an NSERC list of what kind of research are you doing, in a what kind of project are you doing with OCI or whoever it might be. It's not a thing. You can do manufacturing, you can do logistics, you can do verticals, you can do automotive, you can do iMake, actuators or electronics or whatever. There is no robotics, not even physical AI or edge AI or embedded AI. None of those things are an option in those things. And so like even personally, way back in my master's, I guess, maybe it was the beginning of my PhD, I forget. But I was applying for something, it was some kind of funding thing, and I had to basically decide if I wanted to call what I was doing control systems, which lived under computer science, or if I wanted to call it automation, which somehow was different and lived under mechanical engineering, I think. And unbeknownst to me, I checked one box for one application, and I checked the other box in the other application. The content was 99% the same. The one that was under automation went through, and and the one that was under CS did not, because I was an engineer applying in CS. Even though our entire research group was doing control systems on hardware. I wasn't allowed to say control systems because that's for that other silo over there. It was robotics, right? Like I had to try to figure out what the box was. It's just not a thing. So we do not do a good job federally, provincially, anywhere of realizing that robotics is a field as opposed to a like subset of 17 different things,
Sure.
right? Yeah.
Thank you, Maddie. So
Hopefully that answered your question.
Yeah.
It kind of went off the rails a little bit.
I mean, well, it's the perpetual challenge, right? There's not a. As you were talking, what I was thinking through was OCI does have their 6 critical technology areas.
Yep.
Advanced manufacturing is one. AI is one.
Yep.
Quantum, blockchain, 5G networks, which is the connectivity, and
I have robots that use all 6 of those.
all 6 of them. Exactly. And so I'm like, robots is that horizontal
It's all of
layer.
it,
Yeah,
yeah.
it's a horizontal layer. So you need to figure out if your robot's going to be a advanced manufacturing robot, get funding for that, and then use
Well,
it
it's
across.
similar to the
Yeah.
earlier conversation we
Yeah,
had,
exactly.
right? Like people are defining these verticals in terms of application space and horizontals in terms of specific academic things.
Yeah.
But funding is being like, oh, this vertical, but not that part, and that one over here, but only if you're using it in a hospital or in a farm or like. Yeah.
Would you say then that robotics are we talking about an infrastructure layer here that is applicable? I don't want to, I'm not taking it from here to there. What I'm trying to do is say there is a functional layer that applies across many different domains.
Yeah. Well, so the real challenge, I think, is that anytime you try to define, this is one of the reasons I start my classes with what is a robot.
Right.
Anytime you try to define it, it's a moving target.
Okay.
And like one of the things that I've taken to using to help explain some of this is like, we only call things a robot or AI for that matter until it's good at something. Right? Once it's really good at doing something, then it's a dishwasher.
then it
or
graduates,
an
yeah.
autonomous car or a jet
Once
or
it's it gets productized.
yeah. And same on the AI side, right? Like I have
Got
people
it.
coming to me and being like, oh, I want to use AI in blah. And I'm like, cool. AI is this big. Do you mean what people currently call AI, which is generally generative AI and LLMs and VLAs and all of these things? Or do you mean natural language processing and speech to text and image recognition and facial recognition? Because all of those were called AI 10, 20 years ago. Now they're not. Fuzzy networks used to be called AI. Now they're not. Reinforcement learning is not called AI anymore, even though 5 years ago that was like, if you applied for AI funding, it was reinforcement learning and that's what it was. Now it's not, right? So
moving target, but tons of application. So go out there and build things.
And it's an integration layer. So it's not
an
just
integration
infrastructure,
layer.
but it's integration. And
Thank
I
you.
think at this point, it's getting to the point now where, with companies and infrastructure and schools and all the things, at this point we just assume there's connectivity, we assume there's going to be computers, we assume the internet is there, whatever. Robotics is that level of concept.
Should we be then, if I'm a founder at a company, any company, it doesn't need to be robotics though, and there is a problem, not even founder, let's say I'm the executive team and there's a challenge, should I just be assuming we're going to automate this using robots first? Like, is this the go-to, and when it doesn't work, then is this a collaborative?
I think, again, it comes back to more of X, depending on the space that you're playing in, right?
Okay.
If it's a thing that people are bad at or have to have significant domain knowledge in order to do, or it's dull, dirty, dangerous, or whatever, probably there's going to be some automation. Whether that automation is a robot or not, or it's an agent, or it's AI, or it's a really clever tool, like smart insert anything or autonomous insert anything, at some point it was a robot.
Yeah,
but it's
I guess,
not anymore.
I guess what I'm getting
Right?
at
Like
is
yeah.
the range of applications is starting to expand and expand more quickly. So now I'm getting to the point where, 10 years ago, well, we could never automate that. But now I'm thinking, hey, shouldn't we just be de facto at least that's part of the potential solution set to my problem, and that needs to be part of the conversation early.
I mean, it's very similar, and I've had some of these conversations with historians, because we have historians also attached to some of the work that we're doing. It's very reminiscent of like Jacquard loom, Luddites, et cetera, the mechanization of manufacturing, or personal mobility, or like computer, then internet, then smartphone communications piece on the data side, the knowledge side, right? The real major delta here is that it's effectively combining those things, because you have the like mechanized automation mobility piece from steam and industrialization and all of these things where you're moving physical stuff and affecting the physical world, kind of coalescing with all of the communications, personal computing, software, whatever, because really it's like you take the computer and you put it inside the industrial machine, but then you take the industrial machine and put it on wheels and drive it down the road, or fly it, or put it underwater, or whatever the thing is, right? So there's a magnifier effect here that's robots are, in their Mach 2 era.
Right, okay.
Kind of thing, right?
That's helpful, yeah.
Something like that, right? Where it's like it does the thing, but it can also do 10,000 other things, right?
Yeah.
As AI becomes more capable, where do you draw the line between human judgment and robotics autonomy?
So as AI becomes more capable, how do you draw the line between human judgment and AI autonomy? Is that right? All right.
So, I mean, part of the question becomes the input that you've provided. Because AI is only as smart as whatever you've told it. And that is a growing body of information. But as Uche and team can tell you, if you're only giving it video or audio or text or images, it can do really well in that space about things it knows. But it, currently at least, until we've got AGI and it's training itself and knowing when it's actually wrong about things and all of that, which is in progress, eventually I'm sure they'll figure it out. It can't properly learn without being embedded, embodied, being able to affect the world, interact with the world, learn from its own interactions, and adjust its model, which is the critical piece, based on those observations. So sentience is a whole other piece, because that implies that it knows that it is in existence, which is the lovely conversations I have with the philosophers all the time.
Well, it seems like you could put, so the question was, is that because it's not sentient? It seems like you could put the AI, give it the embodiment, give it the tooling with which to adjust its own, to learn from its own mistakes.
So if it was embodied, it had a physical space, it could learn from what it was doing, it had the forces, it had all of the additional things that are not just, YouTube on steroids. You can get it to the point where it can make judgments based on the information it has. But the interesting piece, and we were chatting about this actually a while back, the interesting piece is there is no way, and this is one of the reasons why getting together in a room like this is so important, there is no way currently, and I don't think there will be for a very, very long time, if ever, there's no way for AI, agents, etc., to understand how to combine insights across fields. Because as soon as you start talking about a particular field, it says, cool, this is what I know about that thing. And it's in the little umbrella of like, this is the things I know about a car. And there's no way for it to combine that information with, let's say, its knowledge about a swamp or something, right? If you wanted AI to design you a swamp boat, it's going to put a car on a boat. Right? It doesn't have the capacity, the capability, unless it starts hallucinating and then checking and verifying its results, right? Which is that piece that we were just talking about.
And
right?
is that a horsepower thing?
No, because it doesn't have a concept of that, right?
Okay.
Like really, I mean, the vast majority of AI, there are a couple of interesting ones that are very nascent, but the vast majority of AI is autocorrect on steroids that has learned from how everybody has done something so far to date. It has no idea or concept or ability or capacity or even understanding of how to create, invent, combine anything other than literally like, I have blue and green, I mash them together.
Yeah.
Right?
I
It
think
doesn't
this
have
is
the way to figure out what it's trying to do, I guess. Yeah.
I didn't mean to cut you off there. I'm sorry. Go ahead.
Sorry?
I almost cut you off. I'm sorry. I didn't mean to cut you off.
No. It was it's the invention piece, right? We have a surprisingly efficient processor and random access memory unit and energy efficiency and all of these things that allow us to make connections across boundaries, across disciplines, across silos, across whatever, that is the fundamental reason why we build buildings and go to space and all the different things. And no other thing we know of, place we know of, animal we know of, computer system, et cetera, has that capacity and has been able to demonstrate any of that kind of capacity. Because they are and AI is the same, right? They learn from the body of knowledge they have, whatever they're given. They learn from the new experiences they have, but they are never going to be able to take those experiences and synthesize new things from them because they're just not built that way, right? The whole, like, and you can
seem
charge
skeptical.
through. Sorry, I'm going on a tangent here. You can charge through every sci-fi you want. The only places where the folks who think about this every day, all day long, which is the sci-fi folks and the futurists and things, have actually been able to justify in any meaningful way that an artificial life form system, whatever, has reached the point where it can problem solve and be creative and whatever, is when it is given a body and lives in our society, in our environments, learning from people how people do things and trying to imitate what those people are doing.
Yeah, that is.
Which AI
we're
is
not there
not
yet.
at all doing
Yeah, we're not there
in
yet.
any way right now.
Yeah, I'm going to do
Yeah.
two real quick things. What's the value of people together in a room like this, problem havers, problem solvers? Have you seen that work in 30 seconds or less?
So every symposium we've run, the whole point is not to be a trade show, not to be a conference, not to be somewhere you publish, whatever. It is a place for you to have conversations with people that are not in your bubble. But everybody's in the RoboHub bubble, so it's kind of a weird
Yeah.
thing there. But yeah, and every single one has led to industrial collaborations, companies, sales, startups being formed, new initiatives being created, everything, every single one, because we don't do keynotes, we don't do posters, we don't do papers. It's like you have 5 minutes to give a lightning talk and you will not have the chance to answer all the questions, you will not have whatever, and you will get down and someone else will come up. You won't even answer questions because the whole point is then after that, there's like 2 hours for you to go talk to whoever you still had questions with because it's way more valuable for you to talk to that person and figure out some of those multi-silo, cross-disciplinary things than to sit there for, say, 20 minutes and ask your one question and be like, oh, I'm done talking to this. I don't need this connection anymore.
So I'm going to thank everybody for coming. Thank you, Brandon.
Thank
Big
you.
round
Thanks
of
for having me.
applause.
Thanks for your questions.
We will continue networking afterwards, exactly how Brandon talked. Let's talk and let's solve some problems. If you decide to have a drink, it's on me. It's on us, the first one. After that, it's on you. And you can choose to buy me one, too, after the fact if you want. Or buy Brandon 2 or 3. Thank you for coming. Do you have your phone on you? Can you take a selfie
I can.
with our group here? This is our biggest group ever because it's our first time doing this. So thank you for coming. Thank you, thank you. All right, have a great evening. Look forward to talking to all of you.